And I've been saying all along that anaerobic digesters are a piece of the equation, but only a piece. And if we focus on energy as the only outcome, energy and tipping fees, we're at great risk. And I like KPD, I like Trident Systems and what they've done, because they've gotten very, very good at a piece of the equation. Again, Kerry's got a lot of years in this space. And I like the way they put their system together also, we're going to talk about here, because you can do it in pieces. Right? Sometimes if you want to build a digester, you need to get ready for a tremendous amount of expenditure. If you want to do a complete system, you know, an extraction system can add another $1 million to a $3, $4, $5 million project. It can be difficult to do everything at once. So, down. There you go. So the team at Trident, I also like that very much, because there's a tremendous amount of experience. There's members of that team that have more than 30 years individual experience, and there's nobody on the team that has less than 10. So, and there's a diverse background. Each one of them focuses on a component of the overall solution. Like, so when you bring that together, you get a better product. Yeah, we have, there's 23 installations of varying kinds, including on one of the largest dairy farms in America. We'll see that a little bit later. So we do bedding recovery, we do nutrient recovery, wastewater treatment, and individual components of the system can be selected for different applications. The beginning of the system, we make bedding. This, Mike said about bedding systems are taking on. It's a great way to replace wood, sand, sawdust, all these various things, because you've already got the product on the ground. You're not bringing new things in. And they've really developed their bedding system well in that they concentrate, go through here, they wash the fiber, right? They spend time conditioning it so that only the largest pieces of fiber are what we put back into the barns, which has tremendous benefits for cow comfort, for cow health overall. You can see the fibers as it's being cleaned in the rotary screen. And in the other presentations, we saw some different components. This system brings a number of the components together. The fiber that's left over is quite easy to dry. And if the farmer's not using it as bedding, it can be further exploited into other value chains, higher value products. So the next step, the nutrient recovery system, that's really the driver to assist with anaerobic digesters. It's a patented multi-component organic chemical and mechanical solution. So after the rotary screen, we take the large fiber out, that goes to bedding. The liquid is then moved into a DAF flotation system where we add air, polymer, and retention time into a tank. It takes all the tiny little pieces and floats them together with the small amount of fiber that's left over. You see the sludge, that's what's going into it after. It goes from about 9% solids down to about 4% solids into this system. We mix our polymer on site so that it can be moved very efficiently. It's in bags, it's dry. We rehydrate it with this machine on site. Micronized air, by making the bubbles really, really tiny, they move up through that column, through that material very slowly, gives them lots of time for everything to attach to it. Turns into this sludge. That's going to be somewhere, the sludge itself, 8 to 9% solids. And we skim it off. So you can use that as is. You can put it through normal manure spreading equipment, can be put right on the fields. We're able to get out, and I may be jumping out, but we're able to get out about 85 to 90% of the phosphorus, roughly 50% of the nitrogen, and about 17 to 20% of the potassium out of it into the solid fraction. So it can be used as is. We have a system I'm going to show you here in a second that we can thicken that on site, or it can go further again to palletization or prills or whatever the market might want. So there's a video here, but I don't think the video will play, but I can show if anybody wants to see what that sludge looks like coming off of the DAF system. We use it, it's called an MD press. It's a very low power multi-disc press that moves the material through it. It does what I think you called it a decanter or a centrifuge would do, but with radically less horsepower. It's about 6 horsepower that runs what I think 100 horsepower would take in other machines. And it makes this nice cake, 25% solids roughly. This is the product after it's gone through the MD press. This is a video also that will show, again, if anybody wants to see the videos, I can play them. You can see the difference in the properties in the video easier than a still picture. So like I said, direct land application as it is, thickened or further processed. You can see the liquid that's done after. We're down to about 1% total solids, 1.5% total solids after the complete system. And there's other companies that are doing things that you can take this to drinking water if there's economics, if there's drivers for it. We, at this point, are leaving that to other people to get really good and then join forces with that. And you can put that liquid that's left out through your fertilization system at very, very high rates. So why is this important? It was said earlier. First of all, we can't afford to drive water around, and cow manure, 9% solids, give or take. That's a lot of water to drive around. Large number of animal units produce lots of nutrients. The Fraser Valley has an incredible concentration of animal units on a very small area of land that's always shrinking. It buries all these other applications that the land can't be spread on. And we have an open aquifer, there's a whole bunch of legal challenges, all kinds of reasons that we need to find ways to move the nutrients away. Environmental impacts, progressive scrutiny, cost of fertilizer. We've seen fertilizer costs even in the last 3, 4, 5 years have gone up a lot. Plus also, Victor is here, right? There's discussion about peak phosphorus in the world, that the majority of the world's phosphorus reserves are quite far away, and they'll get more and more expensive as there's more competition. And energy prices are declining, meaning, again, the biogas facilities need to find alternate revenue streams, other ways to pay for the process. What do we know for sure? Every installation is different. We have exactly the same machine at one farm that's processing 30 gallons per minute. That same machine at another farm is doing 310 gallons a minute. So if it's a flush, if it's a scrape, all these different kinds of farms, even in digesters, plug flow, and the different digesters also have different thicknesses. We can really work with any range as long as we can keep it consistent. It's the next slide, automated controls. We still need to have some kind of control over what's coming into it, because whatever you put in the mouth affects what comes out of the other end. The market for separated digester solids is young but emerging quickly. It's a question I get a lot. So we've taken the nutrients out of the water, we've got them into a 25% cake. What now? So right now, as we speak, there is very large investment being done in America with a farm that has our system. They are now building a fertilizer plant that they'll be able to take that into the other streams. It's young. We've been sending out samples, and there's been lots of discussion about how we can best exploit it, turn it into value. Those things are happening. Again, size matters though. A small farm by itself, just like with a digester, it would be difficult to make the economics work. A fertilizer plant needs some volume. So this is a picture. This is Seabreeze Farms in Delta. We've heard lots of discussion about it, and we're going to hear a little bit more later. It was commissioned January 2015. It's Canada's first digester that has a full nutrient extraction system on it. It follows the CH4 biogas complete mix digester we saw earlier in the slides. There's 350 cows when it started, and it's unique in that they have approval for up to 50% off-farm materials. I think that's the highest for any in Canada. It's among the highest of any I'm even aware of. And they're able to do it. They have a very limited land base, but because they've created options for their nutrients, they can do it. They bed their cows on the fiber, and this was made possible by the support of Investment Agriculture Foundation. What happened? Thank you very much. We are all in this together. Yeah. Next one, this is Fair Oaks Farms in Indiana. Interesting comparison. 16,000 cows go into that digester. Right? They make about 3 times the gas of what Fraser Valley Biogas does with 800 cows, because this is only manure. Right? And there's another 16,000 cow dairy across the road, and the scale is a little mind-blowing. There's no off-farm materials in this, and they bed their cows on sand. So they're doing other things with their fiber. We just do the DAF system here. And I can tell you, because it's always the same, it's manure only, the material that goes in. This has been running since April, I think, April of last year. It's a Swiss watch, day in, day out. It's set, and it makes the same cake every day, all the time. And that predictable product makes it easy again for them to take it into that new fertilizer plant they're building. And this is just a quote. Fair Oaks Farms, again, with that many cows, and I don't know if anyone knows the farm. They're the Disneyland of the Midwest. There's I think 30 or 50 or 80,000 people, no more than that. There's a massive amount of people anyways, that there's all these bus tours, and it's a big show. Right? They have all the birthing areas. They said a carnival, they've been trying for a really, really long time to find solutions, and they've spent an exorbitant amount of money and an amazing amount of time trying to find something that works, and they're very, very pleased. When I was there, Mike's quote was, "You're the first guys that ever showed up here that did what you said you're going to do when you said you're going to do it." So kind of a nice thing, feather in our cap, I suppose. And our contact information. Does anyone have any questions?
First of all, thank you very much for your presentation. I liked it a lot. You teased us a bit with a movie in the beginning. Is it still possible to show part of it?
Can you play it? If you go back to the slide here, up. If you got to come out of PowerPoint, I think. So go to the first one. There, that one. Can you just click on the thing? Just click on click right there, Matt. No, double click? No, not going to play? I can show it to you after. Like I said, it just shows the property, what it looks like coming out of the over the weir, and the next one is they say coming off the belt. Yeah, there's videos online, and actually on all the pouches that you have, there's a memory stick in that card that has videos and pictures and a lot of information.
You had one line on one of your slides that said that from the perspective of your technology, digesting coming out of feedstock digestion is really different from early digestion. Can you elaborate?
Yeah. Yeah, sorry. The question was that digestate coming out of a mixed feedstock digester is very different than manure only. Cows anywhere are really the same. When you feed them, the material is very consistent. The fiber content is the same. The liquids content is the same. The more off-farm materials you put in, like at Seabreeze Farms, lettuce, broccoli, cucumbers, oils, all kinds of things go in. That changes it. That's diluting it. And with 50%, it's really, really different. And even within his farm, every single truck that comes in is something quite different. So the predictability, the consistency, the regularity of the product can range widely. Like we see sometimes 2 or 3% solids coming to our system from the digester, and we see sometimes 12 and 14% solids coming from the digester. It's a function of mixing, the timing. There's so many different things that affect it. And again, a complete mix digester is different than a plug flow digester. Right, because with a complete mix, material goes in, it's all being stirred, it's all interacting, touching everything. It's conceivable that material can go in and come out 5 minutes later. In a plug flow, it's like an intestine. You push it in one end, it's got to go through its retention time to come out the other side. So again, you have that consistency. It's really far more the same, which makes automation of controls and managing that product a lot easier. Too long of an answer? Any other questions?
The product at the end, you said could be used as a fertilizer, organic, I would imagine.
Yeah.
The tonnage that you see coming out of there per year? 350 cows.
Yeah. Sorry. Yeah. So the question, how much material? Again, it depends on how much is going in. Like I said, we are pulling out 85% of the phosphorus, 50% of the nitrogen, 17% of the potassium, and the little bit of fiber that's left. I can come up with a number for Jerry's farm, and I can find a number for both farms. I don't know that right off the top of my head.
So for Jerry's farm, at 350 cows, how many tons?
Have you been there?
Yes.
Okay, they fill that room up every day, so that's yeah. I'd have to figure out what that is, but that's I think that room is 15 feet wide by 25 feet long, and it's 2 feet every day, 3 feet every day. I can maybe Dave knows the number. Right. Yeah, it's about 25% solids, roughly. Right, so 5 ton a day. So Dave's going to do a presentation on work they're doing downstream after the system too. Hello, Gustav. Gustav was there at the very beginning and really instrumental in helping the first digester come to British Columbia.
That's not why I stood up.
Oh.
No,
do you think the economics of this will turn out if you get into the markets of whatever that you're looking at for the fertilizer product?
Sure.
And given the sea breeze example.
Yeah, so he's asking where do I see the market going, and I think that there's a huge opportunity, and it's not just in that product, right? Land in British Columbia, I don't know if people from everyone's from somewhere close here, but land is amazingly expensive here, right? And if if you want to have 100 cows to really do a good job of your nutrient management plan, you probably need 100 acres. If you've got a nutrient extraction system and you're doing it, you can do 100 cows on maybe 10. Right? What's that worth? What's the all of the other values? I think that there's going to continue to be other technologies that further exploit it and drive it into value chains. Like I said, we've been working on some projects to take what's left, that tea water, into a shipping container and grow a very high value product. So I think we'll be competitive with other options and definitely reduce transportation. Again, it's that multifaceted return on investment of what you're doing that's going to make it pay.
Chris, Jerry Coolin started, when he put that onto his farm, he had 250 cows. He's now up to 400 and expects to go to 700 within the next couple of years. And he wouldn't have been able to do that without a system like this.
Thank you, Chris.